Okay, in this section we're gonna figure out how to multiply and divide radical expressions and eventually rationalize the denominator. But this video, let's just start with some basic multiplication of radical expressions. So let's say I have the square root of 5 times the square root of 10. Right, and I'm trying to multiply these things together. Well, if I think of these as exponents, this is 5 to the 1/2 times 10 to the 1/2, and what that means is this is really 5 times 10 to the 1/2, because our exponent rules, if I'm taking both of these things to the 1/2 and they're multiplied together, I could have taken their product and multiplied it to, or taken it to the 1/2. So this is 50 to the 1/2, but that's not as simple as we could get. Let's factor this all the way out. This is reduced as far as we can go, and this is reduced as far as we can go. But in this parentheses, I've got 5 times 5 times 2 to the 1/2. And even though there was a 5 here and a 5 here, when I put them together, those two 5s can combine and be pulled outside, right? So this is the square root of 5 times 2. And I've got two 5s together that get to be pulled out front. So I've got 5 square roots of 2 in this case. So we can simplify after we combine everything under the root. So let's look at another one. Let's look at something like 3 square roots of 6 and 2 square roots of 3. Okay, so I'm going to combine these things together, but since it's all multiplication and multiplication happens left to right in PEMDAS, I don't actually need these parentheses. I can write 3 times the square root of 6 times 2 times the square root of 3. And the commutative property says the order doesn't matter, so I've got 3 times 2 times the square root of 6 times the square root of 3. And these are both under the same radical, they're both square roots. So I can write this as 3 times 2 times the square root of 6 times 3. Which the 3 times 2 I'm going to put together because I know that's a 6. This square root, it's 2 times 3 times 3, because the 2 times 3 is the 6. And as a square root, so I get to combine these two guys together and pull them out front. 6 times 3 times the square root of 2. That's 18 square roots of 2. Okay, that was all of the steps to do that simplification, but I get 18 square roots of 2 as my end result. Okay. So let's see another one where I've got the distribution property involved. Let's take, say, 2 square roots of 2 times 4 square roots of 6 minus 3 square roots of 10. Okay, and see if we can simplify this a little bit. So this distribution property still works. I'm taking this times a thing in parentheses, so I get to distribute this to both bits. So I have 2 times 4 times the square root of 2 times the square root of 6. I'm just going to write all 4 of these terms together. I've got my minus sign. Right, all 4 of these go down here. And then these 4, I've got 2 times 3 times the square root of 2 times the square root of 10. I've used the commutative property already there, but I've got just the distribution happening. I wanted to put the radicals next to each other, so I've done that. Now I've got 8. I've got the square root of 2 times 3 after I put both of these under the same square root and factor, minus 6. And I've got the square root of 2 times 5, right? After I put these guys under the square root and factor. So I've got the two pairs of 2's that each can come out under the square root. So I've got 8 times 2 times the square root of 3 minus 6 times 2 times the square root of 5. This is 16 square roots of 3 minus 12 square roots of 5. And I can't combine like terms any further because I got square roots of 3's and square roots of 5, so that's where we stop. Okay, so we can use this distribution property on radicals. We just have to simplify and make sure that we've combined all the like terms afterwards. Well, foiling is just using the distribution property twice, so let's do an example of foiling with radicals here. So let's say maybe I've got the square root of 5 plus 1, and I've got maybe the square root of 3 minus 2. And I want to simplify this or multiply this expression out. Well, FOILing, we take the first guys together, right? I've got the square root of 5 times the square root of 3 plus the outside guys. That's the square root of 5 times a negative 2 plus the inside guys. That's 1 times the square root of 3 and plus the last guys. So 1 times a negative 2. So that's FOILing that out. I've got the square root of 15 plus, well, actually minus 2 square roots of 5. So we're going to make that a minus. And then I've got a plus a square root of 3, and I've got a minus a 2. This is as simple as we can get, right? I'm going to rewrite things in a different order so that I have maybe increasing values under the square root. Doesn't really matter. And either of these two answers is fine. They're the same thing, they're just in different orders. That's pretty much how this multiplication stuff works. In the next video, we're going to see how to rationalize denominators and how division works with these radicals.